Let's have a look at this question involving calculating partial derivatives. So this question asks for the partial derivatives of f with respect to x and with respect to y. And the function is given here as x squared plus 3x ln y. So the technique when calculating the partial derivatives is if I would like to take the partial derivative of f with respect to x, I pretend that all of the y's in the function are now just constants. They're just numbers like 10 or 15 or something like that. And then I just do a regular derivative with respect to x using all my regular derivative rules. Conversely, if I'm looking for the derivative of f with respect to y, I pretend like all the x's are constants and take my derivative with respect to y. So we'll see how this works. So first, let's calculate the derivative of f with respect to x. So again, I'm going to pretend that all of the y's in the function are constants. And then just do a regular x differentiation. So the first term is x squared, so the derivative of x squared with respect to x is 2x, plus the derivative of 3x with respect to x is just 3, and this was just a constant that was just coming around for the trip. So one could think of the second term as actually 3 ln y times x. So 3 ln y would be one giant constant number times x, and so the derivative of that would just be 3 ln y, or just the constant out front. Conversely, if I would like to take the derivative of f with respect to y, now I pretend all of the x's are constants. So pick your favorite number, and you can kind of just in your head think that x is equal to that number. So say x was equal to 10. I would just go through and pretend that all of the x's in here are just 10, and I'm doing the derivative with respect to y. So if all of the x's were just a constant like 10, this first term is just, say, a number, and the derivative of derivative of a constant with respect to y is just 0. So the derivative of this x squared with respect to y is 0. And then we also look here, again, x is some constant, maybe it's 10. So essentially I just have a number times the logarithm of y. So if I take the derivative of this with respect to y, what I get is that constant times 1 over y. Because the derivative of the logarithm of y with respect to y is 1 over y. So if I just clean this up a little bit, the answer is 3x over y.